So in today's video, here is a nice problem. It's coming from a Brazilian Mathematics Olympiad edition 1994. Here is the following information. Suppose if we have A and B as a real numbers, as a positive real numbers, not include number 0, which is A is strictly superior than 0 and B is strictly superior than 0, we have these two following conditions. We have B to the 6 equals B plus 3A. The second equation we have A cubed equals A plus number 1. So the main goal now, we are going to prove this inequality. A must be strictly superior than B. So before we move on to the solution, I would be recommend to give that try to this problem prior get to the solution. And by the way, don't forget to hit the subscribe button and support the channel. Like, comment, subscribe. Okay. Now let's jump into the solution. So before we get started, let's make some kind of exploration for A and B in order to have at least an idea where this A, B are at. Okay. So if I'm going to take B equals number 2, which means I'm going to give the big value of B is approaching to number 2. So we get here B to the 6, which is 2 to the 6, which is 64. We get here at the right hand of this equation, we get number 2 plus 3A. So which appropriate value to give to A in order to have this 64 here? So at least A is going to take almost 20, or little more than 20, or little down than 20. Which means if I'm going to replace A with 20 here, I get 20 cubed. It's impossible to have 21 here, 20 plus 21, number 1. So it's clearly is not going to be bigger than that. Okay, B is very big number for B is not going to satisfy this equation. So which means I'm going to ground this B down between 0 and 1. Let's for example taking B equals half. If taking the B equals half, I get half to the 6, which is 1 over 64, which is very small number. Okay, so if I'm going to make this balance 164 at the left hand side of the equation, at least you're gonna give to A very small number, which is not going to satisfy this equation either. Okay, you will have a very small number here. Let's take the number is more closer to number 1. Okay, if I'm going to take A equals 1, I get 1 here, I get 1 plus 1, which is 2. Okay, so this one looks like is going to be almost, we are going to approach to the appropriate value where we can have this equality. Also, if I'm going to replace B with number 1, I get 1 here, I get 1 plus 3A. A will be replaced with number 1 almost. So I get, we still have a problem, okay? But if I'm going to replace B with a value little more than number 1, for example 1.3 or 1.2, we'll have almost this equality accurate. So which means I'm going to prove these values A and B must be bigger than number 1. Okay, so we are going to do that by the way of contradiction. So by the way of contradiction, suppose A is inferior equal to number 1 and B is inferior equal to number 1. Okay, so we need to take two cases. We need to take A equals 1 and A must be strictly inferior than number 1. So we are going to do two things at a time. So A equals 1, replacing 1 cubed here, which equals 1 plus 1. This one is not satisfied, which means A equals 1 doesn't work because we have this left hand side of this equation have number 1, but the right hand side of this equation we have number 2. Okay, so I'm going to remove this equality sign because of this one. So what about B? B is inferior equal to 1. If I'm going to take B equals 1, I almost have a same thing here. So I will have 1 to the 6, which is 1, which equals 1 plus 3A. Okay, so this one is definitely bigger than number 1, which is not satisfied this. I'm going to remove also this equal sign. I'm going to leave strict inequality because of this. So now we are going to prove these two things, but by the way of contradiction. We need to extract the contradiction for that. Okay, 0 is smaller than A is smaller than number 1. Okay, by given condition. So I'm going to cube both sides, which equals 1. Okay, so I'm going to replace A cubed with A plus number 1. A plus number 1, which is smaller than number 1. Since we get A is strictly superior than 0, this is impossible, because you are going to cancel number 1 from the left and the right. You get A is smaller than 0, since we have A is bigger than 0, which is clearly it's impossible. Okay, which means A is strictly inferior than number 1 doesn't work, which means A must be strictly superior than number 1. Okay, now we have proven this one. We need to move on to the second one, B strictly inferior than number 1. So we know 0 is strictly inferior than B, B is strictly inferior than number 1. I'm going to raise number 6 as an exponent here. I get number 1 here. Replacing B to the 6 with this value, I get B plus 3A is strictly inferior than number 1. Okay, now remember, we have proven A is strictly superior than number 1. So if A is strictly superior than number 1, which means A strictly superior than number 1, I'm going to multiply number 3 by both sides. I get 3A is strictly superior than number 3. Okay, then adding B on both sides, I get B plus 3A, which is strictly superior than 3 plus B. Okay, 1, which means this one 3 plus B smaller than this one. Okay, in the other words, I get 3 plus B is strictly inferior than number 1. It's clearly it's impossible, since we have this one is strictly superior than 0. This is also it's impossible. Okay, which means we have proven also this one. We have proven this one doesn't work, which means B is strictly superior than number 1. Okay, we have proven these two statements. Now let's move on to our proof, where we can use these facts. Okay, now let's get rid of this one and move on to the next step. So if I'm going to compare A to the 6 is bigger than B to the 6, is the same as I'm proving this one. Okay, if I have proven this one, if I'm going to prove this one, that's mean I have proved this one. Okay, so in order to make this one on this form, so for the second equation, I get A to the 3, it will be raised to the number 2 as a power, which means it becomes A to the 6, which equals A plus number 1 quantity square. I'm going to distribute this one. Is given as A square plus 2A plus number 1. Okay, this one is going to be written on this form, B to the 6, which is equals B plus 3A. I have replaced B to the 6 with this one. This is not a solution, but we are going to arrive to this one. Okay, so starting from this one, we get to this one to get us to something true. That's mean our setup is true. Okay, so let's move on. Let's move over this 3A to the left. I will have the following. I have A square minus A plus number 1, which is strictly superior than B. If you remember, we already proven A was strictly superior than number 1 and B was strictly superior than number 1. Okay, so we found two true statements. So since B is strictly superior than number 1, I'm going to put it on this form like this. Then I will have this one A square minus A plus number 1, which is strictly superior than number 1. Then cancelling out number 1 from the left and the right, I will be left. Then moving over this minus A to the right, I get A square, which is strictly superior than A. Since A is strictly superior than 0, I'm going to divide both sides by A. So is taking us to A must be strictly superior than number 1. Okay, so which means we started from this inequality and took us to something true, which we have proven before, which is this one. Okay, that's mean we have proven this inequality, which means A must be bigger than B. Okay, so we're done with this proof. Thank you for watching. I will see you next video. Bye.